Today on the bench we have a Ridgid 18 volt Octane Jigsaw reciprocating saw, and I've already taken a lot of the screws out of this with a T20 to save some time. Well, you know what, I didn't show on video what it was doing, but I'm not getting anything, not even a light or anything. Real similar to a drill that we got that was a Ridgid. They both look fairly new. And sure enough, this is a somewhat similar design where we have, it looks like a brushless motor with a board controller built in for some reason. A little bit different setup, even though the switch still does have a little ribbon cable coming off. This one does have the turn, either potentiometer. We have like a filter board or brake board or something here. Let's go ahead and get this out of the way. Don't give us much more room here. We can take a look at this board, and we'll definitely see TTI on it. This board does have some potting where the drill did not. Let's see if we're getting our 18 volts all the way up here to here. We are right at 20 volts for the fully charged battery all the way to the board. So it's even getting through here, so it's nothing on this board. It looks like, unfortunately, I'm going to have to take all this out to be able to troubleshoot the motor and controller. See if I have any luck. And right off we see something fairly similar to the drill motor that we've seen, except for this has the potting, and it also has the board mounted on the rear of the motor instead of the front of the motor like the drill. We're going to have to pull the stator off of the rotor. We do see a lot of similarities with the drill and the motor that we took apart in the last video. And once again, the motor is like brand new and probably a good design. And then they go and stick the controller inside the motor. And on top of that, they pot it with a hard potting compound and make this one where it's going to be impossible to even troubleshoot, really. Yep, TTI. Yep. I just wish they'd start making them where the consumers could at least repair them. They don't go to the landfill so easy. The cost of this motor combo is probably more than a tool cost brand new, so kind of ridiculous. Well, sorry I really couldn't go much further with this one. We could eventually unsolder this and run it up, which I did that same thing with the look inside of the drill in the video right before this one. If you're interested, we took that motor and ran it up with a little BLDC controller. So this motor appears to be fine. I'm sure it would do the same. A well-designed piece of equipment otherwise. I mean, I could see how this would have held up for years to come if it wouldn't have had the weak link right here. So back now, I do want to cut the board off of this BLDC, and I'm going to unsolder the U, V, and W leads off of this board. So I wanted to try this little cheap hobby driver because it's rated up to 24 volts and rated for high enough current to run this motor. So it comes with a really neat little potentiometer It's already got a plug that will be easy, extremely easy to modify if it works. So I just want to hook it up and want to see how it does. Okay, so back now with this little 3-phase BLDC that we got out of the Ridgid drill in a previous video. We have it hooked up to our 3-phase output of this little hobby BLDC driver with a potentiometer. And I just have 20 volts up to 5 amps coming out of my power supply. Of course, with the potentiometer all the way down, we have 0, and that's great. We'll turn it slowly clockwise. I really like that. So now, just want to take a quick look inside of this. So I have cut this heat shrink since I have plenty of it. We'll take the heat shrink off, and there's our little heat sink plate. Nothing but aluminum plate with a little thermal pad on it. And they have etched off the IC there, but here's a little bit closer look of how the board is made up. You know, for less than 10 bucks, including shipping, I mean, you can't really make a board for this with components. So I was glad I give this a shot. It looks like it's going to work out really, really well for us. It's maybe a makeshift way to run these tools with the BLDC controller built in. I mean, I like the design. I like what they did here, and these little MOSFETs are pretty neat. I think they're called direct FETs. I'll try to put a screenshot up here of the data sheet. And I'm just curious if we could actually repair this one if they wouldn't have put this extremely thick potting on here, as mentioned earlier in the video, that there's really no way to get to troubleshoot. So this is the second Ridgid that we worked on, this brushless, and had a real similar, or maybe even almost identical driver board, although the drill did not have all the potting the disc reciprocating saw had, the Jigsaw. But neither one of them had power component issues. These high-end MOSFETs actually look pretty neat. Only 2 repairs on these I've ever looked at doing, but neither one had a power issue. It's all in the control. And unfortunately here, there's no way to even get to the little microcontroller. You can see the square there, microprocessor there, some other components. I couldn't even get to it to see if we had our 5-volt rail. I'm definitely just going to have to unsolder this one and put it back together similar to this with some wire and lead soldered off of it. So we'll do that, and we'll be right back. Got a new toy here. Seems like it does pretty good. This is a 100 watt with the vacuum pump built in. There's a desoldering iron here. Let's see if you can see this one a little bit better as I start to do this one. Here's it starts to melt there. That is sweet. I really like that. Now all I gotta do is just take my regular soldering iron and lift those right up. I'll continue on and do this side as well, and we'll be right back. So back now with the windings unsoldered from the board, I'm now just gonna put the end of these windings together and put some leads on it real similar to this one, and we'll be right back. Just going to bring down my heat shrink. tried to leave these leads as short as possible to the BLDC. So we'll see how that works out for us. So after tightening the motor down and trying to be even, because this one is not quite as easy to check as this one, to make sure everything's true and torqued down right. But it does seem to be very free, so that's a good sign. So since it's free, before I go any further, I'm just going to hook up a power supply and give this a quick test. Back now with 20 volts hooked up to my BLDC driver. So now after testing the controls, I have now cut the wire going to my BLDC that came with it at the factory with the factory potentiometer. And I don't know if you can see this on camera or not. I can barely see it. It's laser etched on this reddish brown color, and it is not easy to see at all. But trust me, if you have one of these and the right light, you'll see the diagram. And it shows pins 1 being red through 5, and pin 1 and 5 is just a normally open switch, and then our 2, 3, and 4 respectively is going to be our clockwise, our wiper, and our counterclockwise on our pot. So it's just a potentiometer there. So that was really helpful, figuring out how to possibly use this in that regard. So by the way, kind of a side note here, but I did forget to take off my thermal pad or thermal potting off of this board that went across these MOSFETs. So I done so before I put it back together, of course. I didn't want that putty to get wrapped around the motor. So back now with a combination here with my trigger switch, where I'm using my contacts that is normally open and closes when you press the switch. So once you get a certain amount inward, it closes and stays closed for that whole slide. So I'm using that on the red wire to come back, and that's actually just going to come back and go to the potentiometer and go back across. And the wiper is actually attaching to the white wire for the wiper control signal. Power supply on 20 volts here on a test. That actually works quite well. There's a couple combinations of this that would not work, because if you open up a certain part of this, basically it's just going to become open on the wiper, and without being pulled low or pulled to ground, apparently it drifts, and it actually was very high when I released the button to break it. So with this combination here, it actually works quite well. My only other thoughts is, do I want to add this in as well for the thumb knob to be like a trim adjustment, to have it more like it was before, or just simply leave it where the trigger does it all? I'm really torn. I may fool with this for a little bit and see how it goes, and I'll be back on video to go over it with you. So back now, I have this potentiometer mounted back in here because I couldn't remember which direction that needed to go, and I had the wiper tied to the white side here, and the red one's going back to the clockwise part of this one, typically the lower ohm side, back to the wiper through this potentiometer here. So basically the two white ones are tied together here as a trim. So now as we start it with the trigger, I'm going to go easy as I can. I have this down on like 1, I think. Yeah, 1. There we go. I can go up. So I can trim a little bit with that one. And I can also bring this one up and then I can go both. So I think I'm going to leave it working like so. I just have to draw out this diagram so I take it back apart, put some heat shrink on, and solder my wires in. So back now after testing, I think this is how I'm going to hook this up, if this makes sense. I tried to draw this out with a little bit different colors here, but our 5 volts coming from our new BLDC controller on our red wire coming off. We're just going to simply go up and go through the switch and hit this contact point in our trigger switch here. And I drew this out just like it shows on their actual diagram here. And then once this is pressed and that closes, it'll come back around and loop back to the potentiometer. So potentiometer have its 5 volts here, and then on the other side back to ground or our common. So that's how we're getting our 5 volts to be 0 to 5 here. So our 0 to 5 off of this will come out, and now we have it going through what I'm calling a trim, which ain't exactly how they had this before. We're going to have the benefit of having a secondary function of this to be able to trim this down. We're just going to be an inline variable resistor across anywhere from 0 to, I believe that one's a 5K. I'm going to have to double check that, but regardless, it's anywhere from 0 to 5K in series with this potentiometer back to our 0 to 5 volt control. So I'm actually going to take time to shorten some of these wires up and put some solder and heat shrink on here and connect it just like we tested as shown here. But one thing I did want to mention is this controller works very, very good for the money, but there's one thing that may give us a problem. If you can see that, that's a very small flyback diode there. And I am getting some voltage build up across it if I start and stop when I was testing it. So that means that we got a high potential of that diode opening up or shorting. So I may end up beefing that up and putting a higher current diode in it. But I'm actually going to run it like it is and see first, because I may be wrong, but that's just a thought. With that build of a counter EMF or back EMF on a motor stop on the bus, it's kind of going to a higher voltage condition than it may be able to take. But other than that, the board looks really, really good. I'm actually going to tie this push button switch here with a 10K ohm resistor in line with our LED. So I am going to put the LED back in it, and it'll just simply be on if we have this button pressed. 20 volts minus about 3 volts on the LED at about 20 milliamps current. So it's going to be somewhere around 800 or 900 ohms, just, you know, roughly. And I'm going to pick a 1K resistor to drop that voltage at roughly 20 milliamps limiting current. So we'll see how it works. Okay, back now. I am ready for a test. I did have to back out of my LED idea. Everything worked good with the switch. I had to move my wires here to my plus and minus. The resistor would have been great. I didn't realize that LED was bad. I thought I had checked it, but I didn't. And even though I have a lot of LEDs, I did not have a white LED that size, and it had to fit that exact spot. So everything I had was too big. So for now, I just had that LED wire coiled up here so I can put it back later when I do get some smaller white LEDs. But in the meantime, I have my 20 volt battery hooked up, and all my heat shrink is on, everything except for the board. I was going to heat shrink the board kind of like it was originally, and of course put the heat sink and thermal pad back on it. But I'm going to test it first, and then I'm actually going to put the heat shrink over it and tape it with a little bit of electrical tape Then I'm going to put some Kapton tape that won't stretch, you know, over that. And I decided to do that because chances are I'm going to come back and replace that diode as mentioned earlier. So for testing, I'm not going to put the heat shrink on it. Let me rotate this so hopefully you can see it better if I turn the knob here. Wide open. I think that's a pretty good test. Diode just a tad bit warm. I don't know how it's going to do with a lot of starts and stops. So far so good. Back now taped up and safe here. Let's just see how this is looking. See, this should actually go this way, right? So there we go, like so. Everything electrically is fine. I did have to take it back apart because I didn't get this little key right here lined up. If you can see that in the housing, it captures the top of this, the hex of this bolt, and that little key hits that slot there, and I didn't catch that putting it back together. First one I'd ever taken apart just like it. So make sure that's snug and that spot lined up. So my bottom was not going all the way in on the housing, and that's why. So we'll readjust and I'll put the screws back in it. So back now with all the screws in it. I do not have my LED light, sorry about that. I still hadn't got my small LEDs in yet at the time of this testing. That works a lot better now. So back now with just a quick test. It's kind of rainy today, so just threw a board out here on the tailgate of the truck. Do a quick test here. Really nice cut and saw. I'm gonna go ahead and go wide open with it now. After a very successful first test, I'm going to go ahead and put my modified sticker on this Ridgid Jigsaw. All I have to do is go back and maybe upgrade that diode. We'll see. The first test was fine, but I still have a feeling that diode is going to give issues. So if you do something similar, just check that diode. Remember, it can short out on you. If that happened, it would probably blow that fuse too. I also want to go back and add my LED. They kind of tucked the light in a bad spot. On hindsight, I should have just drilled a hole and come out with a bigger one. Probably been better on the outside, honestly. Wouldn't have looked as good, but probably been better. Probably would have worked better. But if you like this video today, looking into this Ridgid Octane brushless motor and the issue that the BLDC built-in controller has, and just a way to get around it to salvage the tool. I mean, maybe not the best case scenario. I would have loved to have been able to repair this. They just did not make it really even possible. I don't know how many of these are going to have similar issues, but I just thought it'd be interesting to see if we could get in that tight amount of space that we had, if we could get anything working without just building it ourselves from scratch. And that was actually way cheaper than doing so. So if you liked the video today, please like, share, subscribe, and thanks for watching.